The world is governed by the laws of physics. Almost every object in the universe must obey these laws. For example, it is widely accepted that when you throw an object on Earth, it moves in a curved path with velocity created by the force of your hand while it is touching the object and by the force of gravity on the object. It is also widely accepted that when two objects of equal mass but different velocities crash into each other from opposite directions, the velocities will switch. It is also generally accepted that nothing can move faster than the speed of light. However, when the objects that we study are extremely small, the laws of physics start to get a bit strange. Very small things tend to obey the laws of physics in different ways, or at least the laws of classical physics. These small things, for example, electrons, obey their own laws. We call these laws quantum physics. For example, entanglement. Einstein called this spooky action at a distance, but this description is a bit of a misnomer. When two particles get close to each other, they become entangled. These particles now share some of their properties. So what does this mean? For this example, we'll say that these particles are electrons. Electrons have a property called spin, and for the purposes of this, we'll say that the two types of spin are spin up and spin down. Here, quantum physics does something strange. It dictates that each of the electrons has a state of possessing both spins until it is measured when it decides on a spin. Now, this sets the stage for the phenomenon of entanglement to happen. When an entangled particle is measured and it decides on a spin, the other particle that is entangled with it instantaneously becomes the opposite spin. So if one entangled electron is measured to have spin up, we know the other electron must have spin down. This phenomenon of entanglement happens at any distance, even across a galaxy, once the two electrons have been entangled. This is what Einstein dubbed as spooky action at a distance. However, as I have said before, this moniker is not quite accurate. This insinuates that the electrons are sending information over the distance instantaneously. This would result in information being sent at a speed faster than light, which we know is not allowed. Instead, it is more accurate to say that the particles are no longer separate objects, due to the fact that they are sharing properties, and instead of sending information, they simply have the information in the first place. The more we learn about this phenomenon, the more that we discover it can be used for. For example, with our current technology, if we had an astronaut on Mars, it would take between 3 and 22 minutes to send information to them, depending on what point the planet's orbits are at. Quantum entanglement, however, can send information instantaneously. In the future, this could result in instantaneous communication with astronauts on other planets.